In this video, we are going to be looking at the periodic table. You would have studied the periodic table back at GCSE, where you would have looked at Dmitry Mendeleev. He was the person to organise the periodic table back in the 1800s, and also how it used to be done by increasing atomic mass, or sorry, elements were ordered in increasing atomic mass, but now it's changed to increasing atomic number. So if I just grab the data sheet, so you will be given this in an exam, and the first thing that you need to know is the divide between metals and non-metals. So all I've done is I've drawn that divide in, and it's not given to you in the exam. You need to know that it starts from, it's like a set of stairs that starts below boron and works its way through. So everything now on the left hand side of that divide is a metal, everything on the right hand side is a non-metal. And as you can see, we obviously have a lot more metals than we do have non-metals. So as I said, that's the first thing that I think you should know. The other thing is to note that it is done by increasing atomic number. So atomic number here is the top number, and as you can see, it goes from 1, 2, 3, 4, and basically increasing atomic number. It was done by increasing mass, atomic mass, but that was before protons, neutrons, and electrons were discovered. Atomic number is essentially just the number of protons found in an atom of that element. The other thing that we need to know is what groups and periods are. So let's look at groups first. So groups are essentially columns on our periodic table. So over here we have group 1. Hydrogen is technically not a group 1. So this row over here are the group 1 metals. This is group 2, group 3, 4, 5, 6, 7, and this is our group 0. Now, as you can see, the numbering that I'm using is written at the top. So the ones I've gone for are the ones in brackets, and this is actually the old numbering system. The new numbering system is the one that is written in bold above over here. And what that does, it ends up including this block over here, which is our transition metals. So our transition metals also have numbers here, whereas according to the old numbering system, the transition metals didn't actually have any group numbers. Now, both the group numbering systems are allowed. I always go for the old one, and that's the one that I'm going to use in the videos, but you can use the new numbering system as well. In terms of the names of groups, you don't need to know all of them, but the ones I would think you do need to know is over here, we've got our group 1, which is our alkali metals. Group 2 are alkaline earth metals. Group 7 are our halogens, and group 0 are our noble gases. So these are the ones that I think that you should know the names of. You don't need to know the names of any of the other groups. What you will find is that in groups, they are essentially arranged based on reactivity. So if I go to our noble gases, they all have very similar reactivity. All of our halogens have very similar reactivity, and so on. So that is how they are grouped in the groups that they're in, based on reactivity. Periods are essentially rows. So period 1 is just hydrogen and helium. Period 2 is lithium, beryllium, boron, and onwards. Period 3 starts from sodium, working its way across like so. Okay, so periods are going across. This is period 1, period 2, period 3, period 4. And so yeah, so you need to know about periods and groups in terms of the periodic table. Right, we're now going to look at a keyword for when it comes to looking at periods, and that keyword is periodicity. So periodicity is the repeating trend or pattern, either word is fine, across a period. So textbook definition, when you do use an exam, make sure you have the term repeating. Don't just say it's the trend across a period. It must be the repeating trend across a period. And we are going to look at some repeating trends across a period in this video and the next video. In this one, we're just going to have a look at electron configuration. So if we look at electron configuration, what you should hopefully, so when you do the electron configurations of these, what you will hopefully notice that when you start a new period, you're going to start filling a new energy level, so a new energy shell. So if we go for period 1, we start filling n equals 1, so the first energy shell. So this one over here is 1s, this one over here is 1s2. When we then move to lithium, which is the next period, we start filling the second energy shell. So over here we start filling the n equals 2 shell, so this is going to be 2s 1, this one is 2s2. As we go across here, we're still in the second energy shell, so it's now going to be 2p1, 2p2, 2p3, 2p4, 2p5 and 2p6. Once we fill that, when we go to period number 3, we're now going to start filling our third shell. So over here we start again at 3s1, 3s2, 3p1 and so forth. When we start period 4, we haven't filled our 3D electrons yet, but as you remember, the 4s fills before 3D. So this one, the potassium here, is going to be 4s1, 4s2. When we get to scandium, this is where we start filling our 3D subshells. So this can be 3D1, 3D2, and so on. When we get to gallium, it's then going to be 4p1, 4p2, and so on. Okay, so in terms of periodicity of electron configuration, every time you start a new period, you start filling the next energy level, the next shell up. So this is going to start filling n equals 1, n equals 2, n equals 3, and so on. So what that does is it essentially gives rise to the different blocks that we have in our periodic table. As we just covered, so these ones over here all fill our S subshell. So this one was, so that's 1s1, this one was 2s1, 2s2, 3s1, 3s2. So for all of these ones here, the outer electron is found in an S subshell. So what that does is it makes this over here our S block elements. So all of these are S block elements because the outer electron is found in an S subshell. With these ones over here, so what I said was were our transition metals here, these ones over here, the outer electron is found in a D subshell, so therefore these are the D block elements, and these ones over here, because the outer electron is found in a P subshell, these are called P block elements. These guys down here, we don't really study them at A level. These are our lanthanides and our actinides. These ones over here, the outer electron is in F subshell, so these ones are the F block elements. So just a quick sketch of that, of our periodic table, very rough sketch. Okay, so this one here is our S block, this is P block, D block and F block, and that is worth remembering for the exam as well.